For many years, Britain has been the world leader in many engineering industries, including power generation, aviation, oil research, and jewellery manufacturing. All of these industries have one thing in common: working with metals. In fact, it wasn't until the early part of the 19th century that working with metals was introduced into UK schools. And this opened up a whole host of opportunities for pupils to learn new processes. In the UK, pupils of all ages experience design and technology by learning how to use tools, work with materials, and follow processes which enable them to solve problems and complete projects. This experience provides pupils with essential life skills which can be utilized and adapted when they finish their full-time education, regardless of what career path they choose to follow. They will be more creative, more confident, and better equipped to solve problems through the ability to think tasks through in a logical process. They will also recognize the importance of working effectively as an individual and as part of a team. The success of an organization or even a nation's economy is heavily dependent on having a workforce of people rich in these life skills and who are comfortable working with a variety of different technologies. Heat treatment, casting, welding, brazing, and hot forging metals provides pupils with an excellent opportunity to enhance their experience of design and technology. Being able to shape, bend, twist, join and cast hot metal would enhance a pupil's CV when leaving school, particularly those seeking a career in the engineering sector. This is why we believe all children should be given the opportunity to experience these heat processing skills in their formal education. Whichever process we select, we must stress the importance of personal health and safety when working with hot metal. Personal protective equipment is a vital part of these activities. Staff and pupils should be equipped with appropriate personal protective equipment. Eye protection, aprons, gloves, leggings, and suitable footwear are vital. Risk assessments, including COSH and CLEEPS assessments, need to be observed throughout the process. These techniques work as follows. Casting. This is where metal is heated to a molten state and poured into a pre-designed and engineered molds before it is allowed to cool. In industry, it is used for items such as car engine blocks, which can be machined, taps, mobile phone covers, plus hundreds of other everyday items. Over 90% of all engineering solutions have some form of metal cast product within its design. Forging. This is where metal is heated to a white heat, which makes it easy to form shapes by using either an anvil or pre-engineered shapes. As well as being one of the oldest metalworking skills, it is most commonly used in agriculture and the arts and crafts industry. For hundreds of years, the forge or farrier's workshop was the focal point of any town or village. The item we are going to produce is the backplate for an item of door furniture, a door knocker or house number. This unit of work fits into the Year 10 scheme of work and relies on the students having undertaken previous work that should provide them with knowledge and understanding to complete this unit of work. The pattern shape is designed on paper and needs to be produced in metal. Initially, a wooden pattern needs to be constructed. This should be the correct size and shape of the finished item. This pattern is produced with a wood-turning lathe until the required shape is achieved. Staff. If the pattern needs a split mould, this is easily achieved by cutting along the length of the finished pattern. Locating pins will have to be added so that the correct alignment between the two halves can be achieved. To begin casting, we need to take one half of the tapered pattern and place it face up inside the drag on a large flat table. A dusting of parting powder is applied to the surface. This acts as a release agent when we need to remove the pattern. The drag is filled with moulding sand, which is rammed to make it firm. Staff, make sure that the sand is rammed into all the edges and corners, as the mould could collapse if there are any gaps. Oil-based sand should be used. If water-based sand is used, it should not be too wet, as the molten metal will cause the water to turn to steam and the mould to explode and the molten metal to run free. Staff, check risk assessments and control measures to establish the correct moisture content of the sand. When the drag is full, level the sand and turn the drag over. You can see the base of the wooden pattern in the sand. Staff, it is useful to have drilled and pegged the two halves to establish the correct position. The cope is then placed on the drag. More parting powder should now be sprinkled over this surface. The sprue pins, which create the channels for the molten metal to enter the mould, can be positioned over or close to the ends of the wooden pattern. The cope is filled with sand and rammed. We can then carefully remove the sprue pins and cut a pouring pool around the pouring hole. This provides a larger target to pour the metal. Then separate the cope and drag. As you can see, the holes made by the pins go through the top layer of sand as far as the pattern. The pattern can then be withdrawn from the cope and drag. It may be necessary to cut a channel from the sprue holes to the pattern void to allow the molten metal to flow into the void. We can use a bellows or bicycle pump to remove any loose sand which may have fallen into the space left by the pattern. Use a piece of welding rod to make some vent holes in the top of the mould. Staff, students should resist blowing or using compressed air, as there is a danger of debris being blown into the eyes. The cope and drag can then be reattached and can be placed in the casting tray. Staff, risk assessment and control measures state that the cope and drag must rest in a bed of sand. This is to contain any spillage of molten metal. It is important that great care is taken during the next stage of the process and should only be undertaken by trained staff. We will be using aluminium which melts at a temperature of 750 degrees centigrade approximately. Ingots of aluminium are warmed and then placed in the crucible and heated until it is molten. Staff. Risk assessments and control measures should be observed. Check the condition of the crucible, preheat equipment, and make sure the ingots are dry. The fume extraction system must be in action throughout the operation. Note its position during heating and pouring. Before pouring, the impurities must be removed. This is carried out by the use of degassing tablets and a rake to skim off the floating slag. Staff. The skimming and degassing should only be undertaken by trained staff. Now the metal is ready to be poured. Staff who will pour the molten metal have personal protective equipment that conform to current regulations. The face is protected by a visor, the torso by a leather apron, arms and legs by gaiters, hands with gloves and feet with spats to cover the shoes. The operation is best carried out in one smooth pouring action. The crucible is tilted in its cradle, so the molten metal flows down one of the sprue holes in the sand. This hole is called a pourer. When the mould is full, the molten metal will appear in the other hole, and this is called the riser. When the metal is visible at the top of both the riser and pourer, the mould is full and pouring can stop. The crucible is returned to its upright position. The crucible should be emptied and allowed to cool. The mould and work has to be allowed to cool. This may take several hours, and although everybody wants to see the outcome, we must wait as the core may still be molten. Staff. Stress that metal is obviously hot when molten, but can still inflict serious injury when cooling. Show that paper can be ignited from a cooling piece of metal. When the pupils have completed their work, the crucible should be allowed to cool down and should have a guard and notice to warn others that it remains hot and poses a danger for a considerable time. The handling of hot metal obviously poses great danger. Please stress the need for pupils to treat this work seriously. It is difficult to tell by observation only if a piece of metal is cold, cool, or hot. Stress the need for gloves or tongs to be used. When completely cooled, the cope and drag can be separated and the remaining sand cleaned from the aluminium casting by brushing. Note the horns on the material. This is where the aluminium was poured into and rose out of the mould. These can be sawn off and the aluminium machined to produce a finished article. The burned sand can be placed in the casting tray. The completed article can then be used for its intended purpose. Staff. Risk assessments and control measures need to be observed throughout the process to allow risks to be minimized. The ability and behavior of the pupils also needs to be taken into account. The movement of pupils carrying hot metal should be restricted within the area. Branding injuries and scorched clothes are just some of the inherent dangers associated with this work. Forging. Many items of metal can be forged. This is when the metal is heated until bright red, then hammered into shape using a hammer, anvil, and various other tools. The forge is the source of heat that allows the metal to become red hot. This is a ceramic chip forge with a natural gas fuel. It is fitted with its own extraction system. Staff. Risk assessments and control measures should be observed. This forge has a number of safety features which prevent it being started without the extraction unit being operated. Check the condition of the fire bricks, the ceramic chips and tools being used. Remove any foreign objects or burned pieces of metal from previous work. We are going to show you several basic techniques which can then be used to form numerous items